Hello, my name is Shiva Mardeshna. I am from Charosat University, CSPAT, and my department is Computer Engineering. Now, today's my topic is transistors. This is the overview what I am explaining about the transistors today. What is transistors? It is basically made of semiconductors and it has an ability to conduct the electricity and can be insulated also and can be either used to flow the current, and it is useful as a switch and amplifiers also. A brief history about the transistors. It is basically invented by Galileo Marconi in it invents and radio in 1895. It was too bulky for most applications. Introduction of transistors. It is originally made of an germanium and currently transistor made of a doped silicon. How transistors work? It is basically made of a doping and adding small amounts of other elements to create additional protons and neutrons, or electrons. And it is doping is basically for p type and n type, in which we can connect that gap between that, and it will generate protons and neutrons, and it will conduct the electricity and electromagnetic field. Similarly, p-types are doped and lacked of fourth valence electron, and n-type it doped an additional fifth valence electron, and its importance is to flow from p to n. Diodes and bias. Diodes are similarly of many kinds: forward bias, revert bias, Zener diode, break voltage diodes, and Zener diode is basically much useful for our case. Types of transistors: bipolar, unipolar, field effective, and metal oxide semiconductors. The bipolar junction transistors are basically the transistor in which they uses both electron and hole of charge carriers. In contrast, unipolar as such as field effective and only use one kind of charge carriers. For these operations, BJT was used for two junction between semiconductors, which is N-type and P-type. BJTs are manufactured in two types, NPN and PNP, and they are available in individual components and fabricated in large numbers. It is basic function of BJT is to amplify the current. This allows the BJT to be used as an amplifier or switch, giving them a wide applicability in electronic equipment, including computers, televisions, industrial control, and radio transmitters, etc. This is the diagram of the bipolar junction diode. It shows how the NPN transistor and PNP transistors are used, and it is used for biasing, and it will conduct electricity, and it will send the message to other transistors. This is the three adjacency region of dope, in which NPM is connected, and two types of BJT, as we know, that NPN and PNP. NPN transistors, it is basically so that it is emitter and have heavily doped than the collector. One thin layer of n p-type and sandwich between two layers of n-type. In this case, the voltage of collector is greater than the base and it is greater than the emitter. BJT characteristics are similarly to gain the current, and it is the fraction of electrons that diffuses across the narrow base region, and L minus alpha is the fraction of electrons that recombine with the hole and base region to create the base current. The base current is basically from the electromagnetic. It is in the direction of electromagnetic fields. Beta is the temperature and voltage dependent. NPN common emitter circuit. Emitter is grounded, and it shows that base emitter starts to conduct with 0.62. This is the example of it, and this is the graph, and how the graph shows, and it will break down if the voltage will be greater than the expected voltage. Common emitter characteristics shows how this active linear or breakdown between the voltages take place, and this is the cutoff region, and BV is basically the breakdown voltage. These are the operation regions: cutoff, saturation, active linear, and breakdown, and these are the values of that. This should be in range only. BJT as a switch, we can use as a switch. This is the circuit of it, how it shows the functionality to be worked as a switch. These are the basic formulas. These are the use case for switch to uh, different types of switches. This is to building blocks for TTL and transistors and logic guidelines for designing the transistors and switch. The unijunction transistors. The unijunction transistors are for short is another solid state 3-terminal device. It is used for gate pulse and time circuiting and trigger generating applications to switch and control either theoreticals or tricks for AC power controllers by the applications. Like diodes, unijunction transistors are constructed from p-type and n-type semiconductors, basically materials from single p-n junction or within conducting n-type channel of this device. This is the diagram of unijunction diode. This is how it is constructed, and it represented in the first part, and its second part is in constructor, and it is simply the equivalent circuit of it. The field effect transistors are the transistors that uses the electric field to control the shape. It is not an electromagnetic field, it is an electric field to control the shape of and hence the electric conductivity of the channel, one type of charge carriers and semiconductor material. FETs are similarly known as the unipolar because they have one part as a single carrier type operation and second part is in several forms which can be high input impedance to carry the charge, while the conductivity of the non-FET transistors is regulated by the input current and so has to low input impedance, which can be FET's conductivity is regulated by the voltage applied terminal, which is insulated from the devices. This is the showcase diagram. Sorry for that blurriness, but I will prepare it basically. Metal oxide semiconductors. Metal oxide semiconductor field effect transistors is a type of transistor used for amplifying the switching electro signals. Short for metal oxide is a method of creating the transistors. MOS consists of 3 layers: metal conductors, insulating silicon layers, and semiconductor silicon layers. This is the diagram of how the metal oxides works in NP and how the photons will penetrate to the channel and potential will be generated between the potential barrier, and the photon generated the electrons and it will pass to the electric circuit. Future of transistors: molecular electrons, carbon nanotubes, nano inspiration wires, CMOS devices which can be used to non-volatile memory or optoelectronic sensing, CMOS technology with new markets, macroelectronics, biomedical devices. Biology may provide also a new technology for bottom-up assembly and human intelligence. What's new in transistors? 3D transistors are used to tri-gate transistors, and this is the size of it. Advance of tri-gate transistors are more than 50% of transistor reducted at the constant performance, which is very good for transistors. 37% performance increases at the low voltage and improved the performance and efficiency. These are the references. Thank you.